At this point, we're going to move forward to exercise 411 in order to consider the following three equivalence rules: commutation, association, and distribution. These three rules go together in the sense that commutation and association are often used in order to set up for the application of the distribution rule. Commutation and association are rules that are straightforward enough, they're unquestionably valid. What commutation allows us to do is take any conjunction or disjunction and switch the order of the two sentences connected by the binary connective. We've seen before, when we're contrasting the way things are with the conjunction, the disjunction, and the conditional, that if the sentence "you are in British Columbia and you're in Surrey" is true, then its mirror image, "you're in Surrey and you're in British Columbia," must also be true. The same considerations hold with the disjunction. Association is obviously valid. It only applies to a fairly unusual kind of situation, however. You've got to have either a triple conjunction or a triple disjunction. As we saw when we were considering the possible uses of brackets, putting brackets around the first two conjuncts in this triple conjunction, or the first two disjuncts in this triple disjunction, don't clarify any meaning, they just preserve binary structure. If we were to move the two brackets from going around the two leftmost sentences to the two rightmost sentences, we're not going to change the nature of the logical commitment. So that's association. Distribution is the one equivalence rule that's valid, like all of them, but it's not obviously valid. We might have to think about things a little bit. There are two versions of distribution. The top one here, we've got a conjunction of some sentence and a disjunction. From that, distribution allows us to infer a disjunction of the sentence that's the left conjunct and one of the two sentences in the disjunction. So P and Q or R can always be validly exchanged for P and Q or P and R. A concrete example: you're going to live in the Lower Mainland and go to Kwantlen or Simon Fraser or both. That would be equivalent to the following commitment about how the world is. You're going to live in the Lower Mainland and go to Kwantlen, or you're going to live in the Lower Mainland and go to Simon Fraser, or both. Once again, we can also assure ourselves that this is valid by thinking about the logical implications of the sentences themselves. So on the left-hand side here, we've got a conjunction. In order for that conjunction to be true, P has to be true because it's the left conjunct, and at least one of Q or R has to be true, so that the disjunction, which is the other conjunct, will be true. Over here, in order for this disjunction to be true, one of these two conjunctions has to be true. So P has to be true, and Q, if that were the situation, then this disjunction of the two conjunctions would be true. Or if it was R, then this disjunct would be true. So this disjunction of two conjunctions would also be true. I may as well be straightforward. This is a little bit of a complicated rule. Because it is a little bit complicated, often students are reluctant to use it, but it's very important to learn how to use distribution, because sometimes you can get into situations where distribution is the only way to complete the proof. So if you're reluctant to use distribution, you'll be cutting yourself off from some very real proof construction possibilities. The other version of distribution says that if a following disjunction is true, where you've got P as one of the disjuncts, the other disjunct is the conjunction Q and R. So, the commitment being made on the left here is that either this is true, or both of these are true, or all three of them are true. That's what's entailed with the disjunction. Remember, disjunctions always make vaguer commitments about how the world is than conjunctions do. The corresponding sentence that we can always validly infer from this bottom one is, well, that must mean P is true, or Q, one of the disjuncts, and P or R. So, if it's P that's true, then since these are both disjunctions, they're both true, so the conjunction of them is true. If it's Q and R that are true, and it has to be one of either P or Q and R, at least one, could be both. If it's Q and R, then P or Q has to be true, because Q will be true. The same with P or R. R would be true, so the conjunction is true. I'll admit it takes a little while to satisfy yourself that these inferences are indeed valid, but distribution is a very important rule, and we have to be comfortable in using it. Here's the simplest case scenario where we can use distribution. This is exercise 411, question 1. What we have in our first premise is a disjunction of a sentence and a conjunction. If you notice, the form or underlying logical structure of the first premise exactly matches the form or underlying logical structure of the distribution employment requirements on the bottom left-hand side. So that means we can validly, by distribution, infer the sentence on the right-hand side, the conjunction of two disjunctions. So, one distribution will give us, let's have a look at the template again, P or Q and R, P or, and it's the left sentence in the conjunction here, so it's going to be A or B, and A or C. So if this disjunction is true, then this conjunction must be true. So that's the distribution step. Notice, once we've done the distribution step, the remainder of the proof, hopefully by now you'll agree, is pretty straightforward. Since the sentence we want is A, and the other premise gives us tilde C, this conjunct in the conjunction in 3, the disjunction A or B won't help us, but the right conjunct, A or C, which we can snap off by 3 simplification. So we've got 2 setup steps, distribution, an equivalence rule, and simplification. Now 2, 4 disjunctive syllogism, that's the basic rule we set up for in lines 3 and 4, gives us A. Next, we could consider exercise 411, question 4. Like question 1, it's a two-premise argument. The second premise is tilde C, and the conclusion is A. Importantly, though, the first premise is different. There's a very important insight into the distribution rule that's illustrated with this particular argument that is going to be very valuable for you in the numerous distribution situations you'll face in the future. To start, we can ask ourselves, which distribution template or situation, if any, does the first premise match? So we've got this disjunction of two conjunctions, A and B or C and D. Clearly, it doesn't match the top left because that's a conjunction and this sentence is a disjunction, nor does it match the bottom right, which is also a conjunction. So, since line 1 is a disjunction, if it does match any of the distribution requirement settings, it's got to be the bottom left or the top right. It looks like it might be the top right, P and Q or P and R. So we've got a disjunction of two conjunctions, which is what line 1 is. On closer inspection, though, line 1, this sentence, doesn't match the employment requirements set out in the top right here, because the employment requirements are P and Q or P and R. This one says A and B or C and D. If the sentence were a little different, let's say, and instead of A and B or C and D, it said A and B or A and D, that would match the top right here. Because the important thing about the top right one is that the left conjunct in the two conjunctions has to be identical. So it doesn't match the top right one either. So what's left is the bottom left, P or Q and R. Does line 1 match that form or underlying logical structure, P or Q and R? It does, and it's a crucial insight to see that it does. We'll hold it here. This is a conjunction on the left, A and B, and this template just has a simple sentence. Here's where it's very important to realize, of course, that since these are all lowercase letters, P can be any sentence. So here's the crucial insight that's necessary and that's illustrated by question 4. We can treat the entire conjunction on the left there, the left disjunct, as P. Then we can treat the left conjunct in the conjunction on the right as Q, treat the right conjunct in the conjunction on the right as R. if we understand the disjunction in line 1 in this way, then it does satisfy the employment conditions on the bottom left. P, A and B, or Q, C, and R, which is D. According to the distribution template, if we have a sentence like that, we can validly infer a conjunction of two disjunctions where the left disjunct in those two disjunctions is going to be identical to the left disjunct in the disjunction on the right here. So what does that mean? What it means is that if we were to do one distribution, tilde C, of course, goes in line 2. I'll put that in later, but I'll leave it out now just so that we don't confuse things. P or Q is going to be P, which is A and B, or Q, which is C, and P, which is A and B again, or R, which is D. So, this is the sentence that we can validly derive from line 1, by distribution. So now I can take out these marks that are illustrating the way in which line 1 matches the bottom left, and I'll put tilde C back in there. Now that we've done the distribution on line 1, once again, I hope this is going to be fairly straightforward to you. The conjunction we would be interested in here is the one that has C as one of the disjuncts, given that we have tilde C in line 2. Not this one, because the knowledge of tilde C combined with this disjunction isn't going to give us anything. So we will do a simplification on line 3, but just take the left conjunct, and once we remove that left conjunct from the conjunction it's in line 3, we don't need the square brackets around it anymore. We've just got a disjunction. One of the disjuncts, A and B, the other disjunct, C. So once again, distribution simplification are two setup steps for disjunctive syllogism, which is going to give us the remaining disjunct, the left one, which is the conjunction A and B. From there, given that we want a simplification, it's going to be used in a little bit of an unusual way for that rule. It's going to enable us to get the conclusion. So that's a very important insight about how distribution can be used. None of these sentences have to be simple sentences. They can be, but they don't have to be. From here we can consider exercise 411, question 7. In this question, we've got that same disjunction of two conjunctions, A and B, or C and D, that we saw in question 4. This time, though, we don't have any other information, and what we're asked to derive from this single premise is the disjunction C and D, or A. Now, we might decide to right off the bat, make use of the crucial insight we saw in question 4, namely that the sentence in line 1 perfectly matches the template in the bottom left, P or Q and R. So we do a distribution on line 1 to get us, once again, A and B, or C, and A and B, or D. Now, given that we want the conclusion C and D or A, which of these two conjuncts should we snap off? Well, the conjunct on the left has A and it has C, which are both required in the conclusion, but it doesn't have D. The one on the right has A and D, but it doesn't have C. So what are we going to do now? Answer. There was a little bit of a problem. We shouldn't have done a distribution on line 1. Rather, we should have done a setup step before we did the distribution on line 1. Namely, a commutation step. So here we're going to take the disjunction P or Q, where both P and Q are conjunctions, and just switch it around so that we have C and D, or A and B. The reason this is going to be advantageous is that now that we've done this switch, when we do a distribution on line 2 instead of line 1, C and D are going to stay together, which is what we need for the assigned conclusion. So, what are we going to get when we do a distribution on line 2 instead of line 1? Well, we're going to get C and D, because that conjunction is now the P or A, and C and D or B. So once we've made the commutation setup for the distribution, our conclusion just snaps right out of there, C and D or A. So with this one, a commutation setup for the distribution that's going to be advantageous to us. So we could have done a distribution on line 1, but it wouldn't have been an advantageous one for getting this conclusion. So we just do a commutation adjustment and then do the distribution, and we can see how advantageous it is for deriving the assigned conclusion. So, having considered commutation, association, and distribution in exercise 4.11, let's now return back to exercise 4.8, question 8, to consider one of the last two equivalence rules. This one is called equivalence. It's the only rule for the biconditional. We've seen in our symbolizing already that a biconditional is actually a conjunction of two mirror-imaged conditionals, and this is in fact the equivalence rule. From any biconditional, you can always validly derive a conjunction of two mirror-image conditionals, or, since it's an equivalence rule, from any conjunction of mirror-image conditionals, you can derive a biconditional. Many textbooks only have this version of equivalence. Some textbooks also have this second version where from any biconditional you can validly derive a disjunction where the two sentences in the biconditional, the two bicons, are either both true or both false. One thing to note about this second version is that from the biconditional you derive a disjunction, which is not a user-friendly sentence. You have to have other information along with the disjunction, most notably the negation of one of the disjuncts so you can get the other disjunct, or it's not a particularly helpful move to make. Whereas the top version, from any biconditional, you can immediately derive the user-friendly conjunction and then just snap off whichever conjunct is going to be most useful to you. So here's a fairly straightforward proof involving the biconditional. It's our only premise, in fact. If it's true, M, if and only if N, then it must also be true that either N is false or M is true, or both of those two. How do we prove this? Using a sequence of rules, which includes the 5 basic rules you set up for, the 3 basic rules you set up with, and the 10 equivalence rules. Notice we only have one premise, so we're not going to be using any of these basic rules you set up for, which require the combination of information from 2 or more, in the case of CD, different lines. What we do is one equivalence and go for the standard, the standard user-friendly version, where from the biconditional we get a conjunction of two conditionals. Now, at this point, the most important thing to consider is what's our conclusion. It's tilde, N, or M. Because the question is, which of these two conditionals is going to be most useful to us? Of course, it's not wrong just to do 2 simplifications in a row, but one of these two isn't going to be especially useful to us. The other one is. Here, the way to answer this question, which of the 2 conditionals is going to be most useful to us, we can ask ourselves, how are we going to get the conclusion, tilde, N, or M? And here, a familiarity with the rules is essential. The way we're going to get tilde, M, or N, given that the only information we have at our disposal is these 2 conditionals, which came from the biconditional, is by implication. So then the question becomes, what sentence are we going to need so that we can get the conclusion by implication? Answer, we're going to need this conditional. So it's our familiarity with implication, that rule, along with the realization that we're going to get the conclusion by employing that rule, that tells us which of the 2 conjuncts in 2 is going to be useful to us. So that's 2 simplification. Now, as planned, 3 implication. So that's how we use the equivalence rule. Later, we might or we might not see an opportunity where it's to our advantage to use the bottom version of equivalence, but it certainly isn't in this case. Finally, we move to the last of our equivalence rules, which is called tautology. T-A-U-T, taut is the abbreviation. Tautology is definitely a rule that appears odd in isolation. Tautology says from any sentence, you can always validly derive a conjunction of that sentence and that sentence. From the sentence, Wayne is in the room, you can always validly derive the conjunction, Wayne is in the room and Wayne is in the room. Obviously, there's not going to be a lot of use for a rule like this. In fact, I had to hop ahead to exercise 412, question 4, to show you an example where this rule is advantageous. So it doesn't come up a lot, but before we consider how to concretely apply the rule, let's just assure ourselves that, like all of our rules, it's valid. That is to say, in the case of the equivalence rules, if the sentence on the left is true, it's impossible for the inferred sentence on the right to be false. And, since these are bidirectional rules, if the sentence on the right is true, it's impossible for the sentence on the left to be false. Well, if the sentence P is true, then the conjunction of two instances of that identical sentence must be true. The same with the disjunction. If P is true, then either P or P must be true. How could that not be? So it's self-evidently valid. It's just that it's not all that clear how we can think of situations where it would be a useful rule to employ. It turns out that almost all of the instances where tautology is useful to employ, and it's a rare enough rule already, are going to be ones where you end up with either a conjunction of two identical sentences or a disjunction of two identical sentences. Now, a key thing to note, though, about tautology, if you're using it from the right to the left, is you're not just doing a simplification step. And for that reason, you can apply the inference from P and P to P on entire lines or to parts of lines. But remember, that doesn't license any simplification. It only licenses, so to speak, simplification where the two sentences in the conjunction are identical. Here's a typical instance of where the tautology rule is actually useful. So, if these two sentences are true, then tilde R cannot be false. How can we prove that, given our now 18 different rules? You might find yourself staring at the two premises, a little bit at a loss, trying to think of how we can combine the information. It's a good thing you've done all the questions in exercise 411, because a distribution step can make our lives a little bit easier here. The distribution I'm talking about is a left to right distribution in the bottom part of the template, if you recall. So from any sentence, P or Q and R, where Q is not R but tilde R, we can always derive the conjunction P or Q and P or R. So, one distribution will give us S or tilde R and S or T. Now, we've got a conjunction of two disjunctions. This disjunction on the right is not going to be of any further use to us because it's not clear how we could combine information in a way that would be advantageous to us. There is no other T-related information, whereas the conjunction on the right here, S or tilde R, has S as well as R-related information, as does the second premise. So we will just do a single simplification. That's going to give us S or tilde R. Alright, so now we've got lines 2 and 4. How can we strategically combine the information in lines 2 and 4? My suggestion, we've got a conditional in line 2. Let's try to set up the other information in line 4 in such a way that we can do a hypothetical syllogism. So that means we need to turn the disjunction in line 4 into a conditional. The rule for that, implication. Before I write down for implication, notice that the sentence as it's set out here doesn't allow us to do an implication. What's the implication rule again? From any conditional P horseshoe Q, you can always validly derive a disjunction tilde P or Q. So what we're going to be doing is a right-to-left implication. So we need to start off with a disjunction where the right disjunct, the left disjunct, the one with the P here, is negated. And then we can get the conditional. We don't have a disjunction where the left disjunct is negated. So, one thing we can do is a double negation, not on the entire line, but on part of the line. So, we'll leave this part of the line exactly the same, but the left disjunct, S, we'll do a double negation just on that. So that's going to give us tilde tilde S or tilde R. So notice, no additional brackets. What does this tell us? Well, this tilde applies to tilde S. This tilde applies to S. This one, of course, applies to R. So what we've done with the double negation is, so to speak, create for ourselves a sentence of this form, tilde P or Q. Notice though with the double negation, P isn't S, P is tilde S. So we've got tilde S or tilde R. So on line 5 we can do implication. So double negation was a setup step for implication. And that's going to give us tilde S horseshoe tilde R. So now we have what we need for the hypothetical syllogism. In line 2, we've got a conditional where the consequent is tilde S. In line 6, we've got a conditional where the antecedent is the exact same, tilde s. 2-6 hypothetical syllogism is going to give us R horseshoe tilde R. When you first see this sentence, you might think it's a contradiction. If R is true, then R must be false. Is that a statement that contradicts itself? No, it isn't. And here's how we can make use of this. Oh, we're not going from line 7 to line 6. We're going from line 7 to line 8. Now that we've done the hypothetical syllogism, let's do another implication, this time on the conditional in 7. So we're doing an implication from the left to the right. So from P horseshoe Q, so P is going to be R, Q is going to be tilde R. We're going to end up with tilde P or Q. So that's 7 implication. Here's an unusual situation, one of the few situations where tautology is exactly what we need. If, and this is what we've proven so far, either tilde R or tilde R is true. At least one of them, possibly both. What we want to do now is employ the rarely used inference of tautology on the entire line, it turns out, where from the disjunction P or P, we're going to validly infer P. Since P is tilde R, from tilde R or tilde R, we infer tilde R. So there's tautology. Doesn't come up a lot, but in this kind of situation, a very useful rule. At this point, it'll be useful for us to take stock of where we are. If you're watching this video on Monday or Tuesday, then test 2 is going to be in about 2 weeks. If you recall a theme that I've been repeating throughout the course, in order to succeed, you're going to have to combine a theoretical understanding of logic along with the internalization of practical skill. And for this second test, the way in which you're going to internalize that practical skill is by doing proof construction questions. Here's the set of exercises that I've made available for you. Assignment 5 consists of exercise 4.2, where there are 14 proof construction questions. This is the simplest possible exercise. There's only 4 rules. I've done some of the questions, but if you were to go to that exercise hours or days after you've seen my demonstration of them, chances are you could approach even those questions as entirely new ones. Assignment 6 consists of question 6, which has 18 questions. Question 7 has 10 questions. Assignment 7 consists of exercise 4.6, 4.11, 4.8, and 4.12, which together consists of 53 questions. Finally, we've got assignment 8, which focuses on exercise 4.13, which has 12 questions. I'm skipping the last 3 questions on exercise 4.13 for now. They're especially challenging. If you can construct proofs for those last 3 questions, that would be excellent, but it's not required. I've set out the exercises in this order. Doing the exercises in this order is going to be most helpful for you to be able to internalize a practical understanding of how to construct logical proofs. Here's the point of doing proof construction questions. First of all, to train your mind to analyze information in a logically flawless way. Most people are fairly logical, but very few people are perfectly logical without having specialized training in thinking logically as we have in this course. So you can think of one benefit of doing proof construction questions to fine-tune your innate logical ability so that you can become logically flawless in the way that you analyze information, instead of being fairly good perhaps, but not logically flawless. The second point of doing proof construction questions is to familiarize yourself with known valid patterns of inference, the patterns of inference illustrated by the 18 rules we've learned, so that you can effectively communicate and justify your claims about the underlying logical structure of various arguments you're discussing or perhaps debating about. Now, I'll just emphasize one more time that when you are engaging in proof construction, another way of looking at what you're doing, you are training your subconscious mind to think about information differently. You have to train your subconscious mind to think about information, or sets of premises, if you like, in terms of valid, recognized patterns of logical inference that can easily be referred to by name. So we use abbreviation for convenience sake when we're doing the proofs, but I also want you to know the names of those various rules so you can more effectively communicate various issues to people if such debate arises. Now, what we're aiming for is that you train your mind to evaluate information in accordance with these 18 logical rules in a spontaneous way. This is going to take time and practice. The practice is doing the various exercise questions. It's also going to take mental effort, especially in the early stages. The more familiar with logical thinking you become, though, here's a bit of good news, the easier and more natural this whole process of proof construction is going to become. You might think of what I'm teaching in this course as, in some ways, like teaching you how to play a musical instrument, or perhaps teaching you how to drive a car with a standard transmission. There's a number of theoretical points that need to be explained at the beginning so that when you are doing the practice part, you have to be consciously aware that things need to be done in certain ways in order for the whole process to work correctly. At the very beginning, these procedures might strike you as awkward and more difficult than they really are. The good news is that the more you carry out these procedures, the more familiar you become with them, they will start to become very natural to you. When you first learn how to play a musical instrument, learning how to carry out various sequences of chords where you have to put your fingers in very particular configurations strikes a lot of people as very difficult. Not only that, you also have to strike the strings or keys of the piano in accordance with some rhythm. It all seems very difficult at the beginning. But the key is, after sustained practice, what initially seemed really, really hard becomes very, very easy. Once a person becomes skilled at playing a musical instrument, they can hold a conversation or they can be aware of various other things because they don't have to use all of their conscious attention in order to carry out the procedure properly. A similar sort of phenomenon arises with learning how to drive a car with a standard transmission. There are a number of things that have to be kept in mind at the beginning. How fast is the car going? How high is the engine revving? Is a turn required or is the car going straight? Where are the other cars? What are the road conditions? All of these issues have to be thought of and kept in one's conscious mind. It's very difficult. Oh, and the last one, of course, what gear am I in? The trick to learning how to drive a car with the standard transmission is to always be in the right gear and going the right speed for the road conditions and the directions in which you're going. It's really difficult at the beginning. Most people stall the engine repeatedly. Hopefully they don't actually drive into something, but it's not easy at the beginning. After sustained practice, though, what seemed really, really hard initially becomes easier and easier. What seemed awkward and artificial initially now seems very natural. You don't have to focus your conscious attention on carrying out the procedure. You will, if you have successfully learned how to drive a car with the standard transmission or play a musical instrument well, you will have trained your subconscious mind not to think about information or sets of premises, but how to carry out certain procedures in a skilled way. Well, the same sort of thing exactly is occurring in this course. So here, the task at hand is to train your subconscious mind to think about information or sets of premises in terms of valid, recognized patterns of logical inference that can easily be referred to by name. What you want to do is get your mind to a point where you find yourself thinking about the information in terms of the 18 rules. At the beginning, it might be helpful to have yourself a sheet where all the rules are right there in front of you. Page 13 of the Some Notes and Exercise Questions has such a sheet. You might want to write out the rules on that sheet in your own writing in order to deepen your familiarity with those rules. The idea is the more exercise questions you do, starting from the easier ones at the beginning and progressively moving to more and more challenging ones, you're going to be training your mind to spontaneously evaluate information in terms of those rules. That's a useful skill that will stay with you. That's a useful skill for designing certain kinds of either essays or systems where you want to make sure that everything's done in a logical manner. For that reason, some people have asked me about this. I'm not going to extend the amount of time you have for the test beyond 90 minutes. As I noted in an earlier email, the test is going to consist of 2 questions like the ones from exercise 4.8, 2 questions like the ones from exercise 4.12, and 1 question like the ones from exercise 4.13. If you have gone through a sufficient number of exercise questions, you will have trained your mind well enough that you will be able to easily complete the test in the time allotted. If you can't complete the test in the time allotted, chances are you've done none or very few of the exercise questions, and as a result, you haven't trained your mind to evaluate information in the unconscious, spontaneous way that you need to. Given enough time, almost anyone could eventually, by looking through the rules, looking at the information, slowly figure out how to construct the proper proofs. What you want to do, though, is train your mind to be able to construct those proofs fairly quickly. What I'm asking you to do is reasonable. I'm not asking you to learn how to construct the proofs so quickly that it's not reasonably possible. But I am forcing you to learn how to construct the proofs reasonably quickly, and I want you to know in advance that the best way to do that is by doing a substantial number or all of the exercise questions so that you have sufficiently trained your mind to begin to spontaneously evaluate information in terms of those rules, and as a result you will have refined your logical capacities so that instead of being fairly good, they are logically flawless. I've posted the solutions for assignments 5 and assignment 6 on the home page. If you haven't already done almost all of the questions in assignment 5 and assignment 6, then you're behind. You need to start working more in this course. You need to catch up, because we're now at the point where we're beginning to apply the equivalence rules to proofs of varying degrees of difficulty. Look for another video. This will be the final video, lecture 7 in the logic class, where I'm going to, this is lecture 7. The final video will be lecture 8, where I will use a number of questions, not from the ones in the exercises, but ones from other textbooks that are at appropriate levels, in order to give you a few concrete illustrations on how to construct proofs. Having said that, though, I can't emphasize enough, you're not going to learn this stuff in the way that you need to learn it just by watching me. There's a certain kind of practical understanding that can't be taught. I can teach you all of the theoretical stuff, but the only way to get that all-important practical learning is by actually doing the proof construction questions. So look forward to lecture 8, which will consist of a number of concrete illustrations of various questions. But this shouldn't prevent you from beginning to systematically go through the exercise questions from wherever you are all the way to the end. So to repeat, test 2 will be in about 2 weeks. So you've got 2 weeks to proceed from wherever you are to the end of exercise 413, also known as assignment 12. Not quite the end, the last 3 questions of exercise 413 we will leave off and consider them after test 2.